Welcome to day 3 of 5.5. This is the last day we will be sending in this section, and tomorrow you will have a quiz on this information. So we have several different types of formulas to look at today, and these formulas may come in to be handy next year when you're in calculus, because you'll learn that it's much easier to integrate with functions when you have a sum as opposed to a product. So the first set round are called the product to sum formulas. So you can see that we start over here with things that are being multiplied together, and eventually we turn them into something where it is addition. There are times when you want to go the other way with it. So if you're given something with addition or subtraction, you might want to turn it into a product, which you'll see in some of our examples today. So for the first one, they want us to verify. So we know whenever we see the verify, that means we want to get one side to look like the other side. So we're going to put up our brick wall. And obviously here, the left-hand side is much more involved than the right-hand side. So if I take a look at the left-hand side, I see some sums going on in the numerator and the denominator. So since we're starting with a sum, I'm going to look at the sum to product formulas, which were the second formulas or the right-hand formulas that are on your piece of paper. And then I'm going to look for the trend. So on top, I see sine plus sine. So I'm going to look through my list and I see sine plus sine as my very first formula. And so that says to expand it into 2 times the sine, and this is our u and this is our v, of u plus v divided by 2 times the cosine of u minus v divided by 2. And then in the denominator, it's the same deal. You're just going to look for this pattern. So I see cosine plus cosine. That would be the third formula down. And so when we change that, that would be 2 cosine of u plus v divided by 2 times the cosine of u minus v divided by 2. Okay, obviously we can clean this up a bit. On top, if I add up our sum, we have 10x over 2, and so that would give us 2 sine of 5x, and this is going to be 6 minus 4, or 2x divided by 2, so this is going to be the cosine. Go back, where it is? Where is it? There it is. The cosine of x divided by 2 cosine of 5x cosine of x. Okay, now I'm going to look for things to cancel. The 2's obviously are in common. We have a cosine of x and a cosine of x here. And so now all we are really left with is the sine of 5x over the cosine of 5x. Since they have the same angle value, we can combine that to the tangent of 5x, which is good because that's exactly what we wanted to get. Next, you can use these formulas to help you to manipulate when solving equations. And we've been solving equations pretty much all through chapter 5. That's been the big theme. So if we look here, the big problem is we have the same trig function. We have sine, but we have 2 totally different angles. And we know from our experience that's not a good thing. So since this is a difference, or another way to say a sum, I'm going to look to say sum to product again. And if I look at my sum to product formulas, it's the second one on the paper. So I'm going to use that sum to product formula to make this look a little bit better. So if I use that formula, you're going to get 2, and again, this is our u and this is our v, 2 times the cosine of u plus v divided by 2 times the sine of u minus v divided by 2, and this equation will equal 0. All right, we're going to clean this up. This is 2 cosine, this is 6 over 2, which is 3x, times the sine, this is 4 minus 2, or 2x divided by 2, which is x, equals 0. Okay, to solve it, this is already all factored for us. We have multiplication here, multiplication here, multiplication here. It's like putting parentheses in. The 2, we don't worry about it because 2 can't equal 0. But what we have is the cosine of 3x equals 0. And we have the sine of x equals 0. And we're looking from 0 to 2 pi, which means we're looking one time around the circle. So I'm going to do this side first because it's a little bit easier. And so where does sine equal 0? That's going to happen at 0 and pi. So my answers from this piece are going to be 0 and pi. When we go over here, remember when we have a triple root, the easiest way to do this is to solve for all. So we're going to think about all the places where cosine is equal to 0, and that happens at pi over 2 and 3 pi over 2. So I can call this pi over 2 plus pi n equation. And then we're going to solve for x. So we're going to divide everything by 3. And so this is pi over 6 plus pi over 3n. And then remember, we are trying to solve from 0 to 2 pi. So that means that we're going to put numbers in for n, as many as we need to. And we're going to start with 0. So that's going to give us pi over 6. And then we're going to go to 1, and that's going to give us pi over 2. And then we're going to put in a 2, and that would give us 5 pi over 6, and so on. And if we put in 3, then we get 7 pi over 6. And I just keep going. 3 pi over 2 would be the next one. And 11 pi over 6 would be the last one. If we put in anything higher than that, we're going to be over 2 pi, because 11 pi over 6 is already very close to 2 pi. So all of our answers would be these, and then these two over here. So that's our total answers for this problem. Next problem, did I skip one? I did. Find the exact value of the sine of 195 plus 105. So obviously 195 and 105 are not on the unit circle. However, we can probably use a formula with a sum to product to turn this into something maybe where we could get an exact answer without a calculator. So the sum to product formula I'm looking for is for sine plus sine again, which is the first one. So we have 2 sine of 195 plus 105 divided by 2 times the cosine of 195 minus 105 divided by 2. And I'm just being lazy with my degree symbols. So this is 300 divided by 2. So this is the sine of 150 degrees. And this is 195 minus 105, which is 90 divided by 2. So this would be the cosine of 45 degrees, and we have a 2 sitting out there. So the sine of 150 degrees is 1/2, and the cosine of 45 degrees is the square root of 2 over 2. And so our final answer would be the square root of 2 over 2 for this problem. Next one, rewrite this as a sum or a difference. So this is where you might want to do this next year before you would integrate this trig function here. So this is already written as a product. Oh, you don't want to write for me. Oh, is it going to freeze? Please don't freeze. Ah. Okay, maybe I'm safe. Product to sum formula. So now you're going to look at the left side of your paper, and there's a product to sum formula that involves taking the sine times the cosine. It's the third one down. So you're just going to follow the pattern that it says, which is 1/2 times the sine. Again, this is u and this is v. The sine of u plus v plus the sine of u minus v. And so this is 1/2 times the sine of 8 theta, and this is all in parentheses, plus the sine of 2 theta. And it would be easier to take the integral of these two things separately than it would that product up there. Last set of formulas we have today are called the power reducing formulas. And these are when you have something that's higher than degree of 1, we have degree 2, and it's going to turn it into something of degree 1 because it will always be easier working with something of degree 1. So this one has degree 4. And they want you to write all of your answers with first degree only. So the first thing you're going to do is think of another way to write the sine to the 4th x, which would be sine squared x times sine squared x. And now we can use one of our formulas, which is this first one. So in for sine squared, I am going to put in 1 minus the cosine of 2x divided by 2. And 1 minus the cosine of 2x divided by 2. And as we're writing this, you might be saying, wait, I remember that formula. Well, if you took the square root of both sides, you would have the half angle formulas that we talked about the other day. So that's where these are coming from. They're coming from squaring both sides of the half angle formulas. Okay, so we need to simplify this more. So obviously, we're going to multiply on top, which means we're going to do some foiling. So you're going to get 1 minus 2 cosine of 2x plus the cosine squared of 2x, all divided by 4. And by doing that FOILing, you got cosine squared that just popped right back into the problem, and now we got to get rid of that. Okay, so we don't have a formula for the cosine squared of 2x, but we do have cosine squared of u. So you need to manipulate that in order to substitute it in here. So the cosine squared of 2x, which is going in for u, is going to be equal to 1 plus the cosine of 2 times 2x divided by 2. So we're going to put in here 1 plus the cosine of 4x divided by 2. And then the rest of this is still there for us. So plus, we got the cosine of 2x and 1 minus that, and this is all still divided by 4. So we still have some cleaning up to do. Hopefully you see on top we need a common denominator. So I'm going to put this over 2 and turn this into a 4, and I'm going to put this over 2 and turn this into a 2. So now on top I have 2 minus 4 cosine of 2x plus 1 cosine of 4x. And technically this common denominator of a 2 is now down here with the 4, and it's an 8. And then finally we can combine some like terms here. So that would become a 3. So 3 minus 4 cosine of 2x, I missed a plus in here, plus the cosine of 4x, and that's all divided by 8. And there's your final answer. So again, this is now taking something that was a product and writing it as a sum or a difference. And this will be something that you will need to do next year in calculus when you do your integrals. Okay, last one. Just like we did with the last one, we're going to do another one, but this time it'll be with tangent. So the tangent of 4x, or tangent to the fourth of x, is the same thing as tangent squared of x times the tangent squared of x. And if I look at those power reducing formulas, I'm going to substitute in here 1 minus the cosine of 2x over 1 plus the cosine of 2x. Again, probably looks familiar because it's from the half angles. And this is 1 minus the cosine of 2x over 1 plus the cosine of 2x. Okay, so like we did before, we're going to do some FOILing. So we FOIL on top, and we get 1 minus 2 cosine of 2x plus the cosine squared of 2x. And there's our squared term that popped right back in again. And now I have 1 plus 2 cosine of 2x plus the cosine squared of 2x. So we got to take care of this guy and this guy. So like we did in the last problem, we got to substitute, and we have to do a little bit of substitution for our substitution. So in for the cosine squared of 2x, we need to make that equivalent to 1 plus the cosine of 4x divided by 2. And in the denominator, I have 1 plus 2 cosine, this is a 2, of 2x plus 1 plus the cosine of 4x divided by 2. Okay, we need some common denominators again. This guy's going to get a common denominator. This guy's going to get a common denominator. Same with this guy, and same with this guy. So now we have 2 minus 4 cosine of 2x plus 1 plus the cosine of 4x. Everything now is to the first power. This is all divided by 2. Then divided by, in our denominator, we have 2 plus 4 cosine of 2x plus 1 plus the cosine of 4x divided by 2. All right, luckily, what happens to these 2's? If we reciprocate and multiply, they're going to cancel. So let's take a look at what we have now on top. These 2 can combine, and we have 3 minus 4 cosine of 2x plus the cosine of 4x. And on the bottom, these 2 can add up and get 3 plus the 4 cosine of 2x plus the cosine of 4x. And that's really all you can do with this problem. So you're done. Okay, so you have your practice to do. The homework answers are already on Blackboard.